at this problem where we're told to suppose that x and y vary inversely. They want us to write a function to model the inverse variation. So here we're told that x is negative 4/15 when y is negative 105. That's our given information. We have to know that inverse variation functions will take the form y equals k divided by x instead of y equals k times x for the direct variation. And then we can plug in what we know. We know that y is negative 105. We don't know k. That's what we're trying to figure out right now. We know that x is negative 4/15. We need to go ahead and solve that for k. We can multiply both sides by negative 4/15. On this side, that would cancel with that. On this side, I need to multiply by negative 4/15 right there. I'll jump back up over here. Negative 4/15 times 105. Well, I know right here that 15 actually goes into 105 7 times. So I can cross this off, and make it a 7. I've still got the negative there, so I'll go ahead and I'll make that a negative 7 there. So I have negative 4 times negative 7. That's going to be what k is equal to. Negative 4 times negative 7 is 28. So the value of k, or the constant of variation, for this inverse variation function is 28. Now that I have that, I can go ahead and actually write the function as y equals k divided by x. So my function would be y equals 28 over x. And here is my function for this inverse variation. Now we can take a look at this and use this function to figure out some values of x and y if we're given one or the other. If we want to go ahead and find y when x is 10, now that we already have our inverse variation function, we just need to go ahead and plug in the 10 for the x. So here we have y equals 28 divided by 10 with that. And we can go ahead and simplify that a little bit. Both of those are divisible by 2. That would make 14/5 for that. Or if you prefer the decimal, that would be 2.8 as well. Both of those are equivalent answers. It doesn't really matter which one you would say for that. I would accept either one of those. That's a simplified improper fraction. And this is an equivalent decimal. It's not a rounded answer for that. So 14/5 or 2.8, either one of those is good. Now we'll use our function to find the other variable. We still have our inverse variation function, y equals 28 over x. But now they want us to find x when y is 7. So I'm going to go ahead and plug in the 7 that I know for the y. So I have 7 equals 28 divided by x. Again, you may be able to look at that and say, well, I already know 28 divided by what? I know what that is going to be 7. That's fine. I do too. If you don't, to solve this algebraically, you'd multiply both sides by x. That would give you 7x is equal to 28. And then you go ahead and divide both sides by 7. And you have x is equal to 4 for that. So we used our inverse variation function to find the value of x to be 4 when they told us the value of y was 7. And that's how you would go ahead and do that and use write the function and then use the function to either find x or y.